Now we are going to use our attribute selection method. The first one is filter. Filters assess each one of the variables regardless of the response, but the main characteristic that filters have is that the method used to predict does not intervene. So in this case, KNN does not intervene until the end. Instead of that, we use different measures for information. So for this, we use this package called FSINR, and we can put it here as filter. I'm going to use English filter evaluator. So the first thing that we're going to do is to tell R which one is the indicator that it's going to be used as a filter. There are several different indicators. You can see them in help. So this is the function filter evaluator. So I'm going to use this in help to check what possibilities I have to use the filters. So there are several here: binary consistency, chi-squared, Kramer, determination coefficient. So which one to choose? Well, that depends on if we know the problem that we are approaching. The most recommended is one of these. Also depends on the scale of the variables, if they're numerical or if they are qualitative variables. It could also be important to take this into account before identify which one's going to be used. Kramer is very flexible. This is a value that it goes from 0 to 1. If it's 1, it means that it has more information. So I'm going to use this one, Kramer. I could use any of the others too. And we also have two variables here that the response variable will be numerical. And there are some variables in our database that are categories and other variables that are numerical. So Kramer in this regard is very flexible. I'm going to use the evaluator, the filter evaluator. The next to define with the filters would be the variables that we are going to use to measure the Kramer index. So I'm going to do it on all of the databases. So I need the name of the variables, all the variables. These are the variables. Obviously, I don't need the yield because this is based on the yield that I'm going to calculate that information. So I'm going to remove number 26. Now what I'm going to do is to calculate the Kramer value with this function, Kramer v. That's the object that I'm going to create to store those results. The function used by the package, it's called filter evaluator, this one. The first argument are the data that we're analyzing. This is called datos. Next argument would be open quotation marks. I'm going to indicate the name of the response variable, RDT, plant. This means plant yield. And next, the variables that we want to use to perform the calculation. So control enter, and then let's see what's the result. So we have a Kramer value. Remember that goes from 0 to 1. The closer to 1 it is, suggests that the variable has more information, so it's worth a while to keep it. So we can see that there are high numbers. The lowest one is 0.77, but we have 0.80, 0.81. So we use filters. Usually we use a threshold to reduce the amount of variables. To do this, it's better to have everything organized. So what I'm going to do is to create a data frame where I can visualize all these variables more easily. So I'm going to create it here, data frame. So first I'm going to tell that the first column will be the name of the variables. We've already read it here before. We are going to keep the same order, and I'm going to include the value of Kramer. Kramer V equals to Kramer V. So apparently I'm missing something. variable. Here it is. I missed an S. There you go. However, it's still very hard to read it because it's not in order. So to organize it, I'm going to save this data frame. We're going to save it in the data set called dataset Kramer, DS Kramer, DS Kramer here. But I'm going to indicate that I would like to add an order. So we can do it by doing this. Order is going to throw back the order of this vector that I'm going to include here. So this order is going to be based on the same Kramer matrix, but I only want to organize Kramer V, and I want to do it decreasing and equals to true. So here we go. This is the order of the most important variables, and they should go from the highest number to the lowest number. So this is easier to read. Right here we can also choose the threshold, which hasn't been established. It depends on the investigation that we want to carry out. So we don't have variables with a low Kramer in this case, but we're not analyzing a method that involves several variables simultaneously. So I'm going to put that threshold in 0.80, and I'm only going to keep the data sets and the variables that have a Kramer coefficient of minimum 0.80. This could be very rigorous. We probably have some relevant information here because the information is very, very small. But I'm going to do it just to test it. So I'm going to put here DS Kramer. I'm going to save this matrix. And I'm going to say that I want to cut those variables to remove them from the matrix. So I'm going to say DS Kramer. I'm going to extract the variables, the name of the variables here. But I'm going to include the rule now. DS Kramer. I want all the Kramers that are over or higher than 0.80. And there you go. So it's only going to remove the others. I have pH, Bio 12. Yeah, here they are. So that's my selection. Selección filtros, or filter selection in English. And what I'm going to do now is to train the model once again with the same train option in order to avoid doing it from scratch. So I'm going to use this, the set.seed. I'm going to bring it down here. And I'm going to tell it that in data, I'm going to open brackets here, and I'm going to choose only the selection filters variable that's here. I'm going to put it here. Remember that in this case, it's only going to affect the columns, which are the same ones that were identified by the filters, and I have to add the response variable also, because I cannot cut it. This is a response variable. So I'm going to leave it here, rendimiento plantas, or plantain, not plants, but plantain. If you notice, the only thing that I did in this segment here was to cut the matrix with the variables that I chose with my filters, and finally, I'm going to keep my response variable. So let's update it. I'm going to remove this one because it wouldn't be the complete model. It would be the model with filters. Let's execute it. KNN is very fast. That's another one of the advantages. And let's see the results. There you go. The K is equal to 7, and the best K is 7.10. 7.10, and we can compare with the complete model here. There's not such a big difference between the best value here with 13. We had 7.10 for the complete model. And here we had with 7, almost the same point, 7.10. These are very similar values. Actually, the model with filters improves, but very slightly. However, we're reducing the amount of variables from 25 predictors that we have in the complete model down to 11 predictors. So this model is a lot simpler. So this would be with the attribute selection by using filters. And up next, we're going to see the way to do this for RAW Press.